Let's take a look at some compound inequalities. Now remember, a compound inequality is basically just two distinct inequalities that are joined together by either the word and or the word or. So think of it kind of like a two for the price of one inequality, where we have two inequalities that we're combining to make a single compound, to make a compound inequality. So we're going to take a look at a couple of examples here. The instructions say, write a compound inequality that represents each phrase. Graph the solutions. So let's take a look at part A. In part A we have all real numbers that are less than or equal to -2 or greater than 1. So we need to write that as a compound inequality. So let's take a look here. We've got all the numbers that are less than or equal to -2. Okay, so we have a less than or equal sign. And so all of our numbers that are less than or equal to -2 would be represented with this inequality. X is less than or equal to -2. Now we're also talking about all real numbers that are greater than 1. So all the numbers that would be greater than 1 would be represented as X is greater than 1. Now before we graph the solutions here, I like to go ahead and write this compound inequality in both set builder notation and interval notation. With set builder notation, we would say that the possible solutions are represented as X as an element of the real numbers, such that X is less than or equal to -2, or X is greater than 1. So that would be our set builder notation. So we're basically saying that X can be any number in the set of reals as long as it's less than or equal to -2, or it's greater than 1. Now to write that in interval notation, we've got two inequalities here. So we're going to have two intervals. We have the interval that's any number less than -2 up to and including -2. So all the way down to -infinity up to and including -2. Remember, when we include the number in interval notation, we use a bracket. But that's only part of the inequality. We're going to combine that, or we have the union of this other interval, which is everything from 1 up to infinity. Notice I'm not including a bracket, but rather a parenthesis, because 1 is not included in this interval. So to graph that, what we would do is represent that as we would show that we have an interval from -2, so let's find -2 here on the number line. Now we're including -2, so I'm going to fill that in to represent that 2 is included in that interval, and every number less than -2. In addition, we have a starting point of 1, and all the numbers greater than 1. We're not including 1 in this interval, but it gives us the reference of the possible values. And so there you have the graph of that compound inequality. Take a look at part B. We have all real numbers that are less than 5 and greater or equal to 0. So less than 5 means that we've got a situation here where we say that X is smaller or less than 5, so any number less than 5, and X is any number that's greater or equal to 0. So to write that compound inequality in set builder notation, we would say that the solution is X, any X that's an element of the real numbers, such that, now in this case, because this is an AND compound inequality, I'm going to put the variable in the middle. We're going to say that X is less than 5 and it's greater than or equal to 0. So there we have our set builder notation. Um, Now, before we do interval notation, we're going to go ahead and graph this, and then I think the interval notation will we'll be able to see that and understand that a little bit better. So when we graph that, our x is anything less than 5, so here's 5. So it's anything below 5, so I'm just going to draw an arrow pointing to all the numbers that are less than 5. But it's also any value that's greater than or equal to 0, so there's my 0. Since 0 is included, I'm going to fill that in. And it's everything greater. So as you can see, um, the actual possible solutions are any number between 0 and 5, including 0. So to write our interval on that one, we would say that the interval is, let's see, we have everything from and including 0 up to 5, but not including 5. Okay. Now let's take a look at this next compound inequality. The instructions say solve the compound inequality, graph the solution. So our inequality reads 8 is less than 2b, add 4, which is less than or equal to negative 10. Now, some people like to leave the inequality like this and just perform the operation on both sides at the same time. I usually like to just, for clarification, I like to separate my inequality, my compound inequality, into the two um, distinct inequalities, just so that I can see what's going on. So here we have 8 is greater than 2b add 4, and 2b add 4 is greater than or equal to negative 10. Now we can just go ahead and solve those one at a time. Again, we're trying to isolate the variables, so using the subtract property of inequality, we can subtract 4 from both sides of the inequality. So we have 4 is greater than 2b. Using the division property of inequality, we can divide both sides by 2 in order to isolate the b. 2 divided by 2 is 1, so we have b is less than 4 divided by 2 is 2, and an equivalent inequality would be b is less than 2. So here we go. 2 is greater than b, or b is less than 2. Either statement is equivalent. These two statements are equivalent. Now, over here we have 2b add 4 is greater than or equal to negative 10. So again, we'll start isolating the variable by subtracting 4 from both sides of the inequality. That gives us 2b is greater than or equal to 4, take away 4 is 0, and a negative 10 take away 4 is negative 14. So now to isolate b, we divide both sides by 2. 2 divided by 2 is 1, and so that leaves us with 1b, which is greater than or equal to a negative 7. Okay. All right. Now, as far as graphing, on a number line, we could just say, well, I know I'm going to have a negative 7 over here. I'm going to have a positive 2 over here. According to my inequality, b is less than 2. So I'll do so any number less than 2, but not including, and b is greater than or equal to negative 7. So we include negative 7 and all numbers greater. So the area, or the interval of numbers that satisfy that solution are between negative 7 and 2, including the negative 7. Now, just for fun, let's write the solution in both set builder notation and interval notation. So our set builder notation would be that b is an element of the real numbers such that b is greater than or equal to negative 7 and b is less than 2. Now, to write that in interval notation, we're going to use a bracket because we're including 7 as the beginning of the interval on the left-hand side and going up to the number 2, but not including 2, so we'll use parenthesis on that one. And there you have the graph as well as the interval and set notation.